Vector addition overview. The resultant vector R is the vector sum. It's a single vector that has the same net effect as all the vectors being added. Symbolically, the resultant vector, which we can write either with an arrow above it or bold letter, is vector A plus vector B and plus as many vectors as are being added. Vectors have both magnitude and direction, but the resultant vector cannot be found by simply adding the magnitudes of each vector to each other and adding the angles of each vector to each other. To find the resultant vector, we must find both the x and y components of each vector being added and then find the sum of the x components to find the x component of the resultant vector, and then likewise sum the y components of each vector, find the y component of the resultant vector. Symbolically, resultant vector x component is the x component of the first vector being added, here a sub x plus b sub x plus and so forth. The resultant vector's y component is also the sum of the y component. To do this, we have to use what we learned before. Recall that the x component of, say, vector A is plus or minus, the SIGN must be manually prefixed, magnitude of the vector, here A, times the cosine of the reference angle, a sub y is plus or minus magnitude of the vector times the sine of the reference angle. Steps for finding the resultant vector. To find the resultant vector are the vector sum A plus B plus many vectors are being added. First step, find the x and y components of each vector. The x component of the resultant vector is a sub x plus b sub x and so forth. R sub y equal a sub y plus b sub y and so forth. The x component of each vector, in this case a sub x, is plus or minus magnitude of the vector times the cosine of the reference angle, and the y component is plus or minus magnitude of the vector times the sine of the reference angle. Next step, find the magnitude of the resultant vector using the Pythagorean theorem. Magnitude is the square root of the sum of the squares, or the square root of the absolute value or magnitude of the x component of the resultant vector squared plus the magnitude of the y component of the resultant vector squared. Demonstration problem. A ship travels 130 miles on a course of 68 degrees west of north, vector A, then travels 58 miles on a course of 30 degrees north of east, that's vector B, this is 30 degrees, then goes 92 miles due south. It then breaks down and has to be rescued. What is the displacement vector that a Coast Guard ship must set to go directly from the starting point of the distressed ship to its final position? Note that when you draw vectors tail to tip, as we've done here, the resultant vector, the vector sum, the single vector that replaces all the vectors being added, is the vector from the first tail to the last tip. We now resolve each vector into its components. Note that for vector A, 68 degrees west of north is not the reference angle, as the reference angle is the angle between the vector and the positive or negative x-axis, whichever is the shortest direction. In this case, the reference angle for vector A is 90 degrees minus 68 degrees, or 22 degrees. Looking at vector A, it's in the second quadrant, we see that the x component is hypotenuse or polar magnitude, or 130 miles, times the cosine of the reference angle 22 degrees, and that it is negative. This is the negative x direction. The y component is positive. That's the positive y direction. It is 130 miles times the sine of 22 degrees. Vector B is 58 miles, 30 degrees north of east. This places vector B in the first quadrant. Theta, being 30 degrees, first quadrant, is also theta ref. B sub x is 58 miles cosine of 30 degrees, which is positive, these are along the x-axis. The y component for B is positive, parallel positive y-axis, 58 miles sine of 30 degrees. Vector C is due south, magnitude 92 miles. It has no x component at all. B sub x is 0 miles. Y component, this is in the negative y direction, is minus 92 miles. We calculate R sub x, or the x component of the resultant vector, and we get minus 70.3 miles. And R sub y is minus 14.3 miles. Notice that the fewest number of significant figures is 2, that we have carried one extra decimal place, so as to not propagate round-off error for intermediate steps. Since the x component of the resultant vector is negative, as is the y component, the resultant vector is in the third quadrant, which is consistent with our drawing. Step 2, find the magnitude of the resultant vector R using the Pythagorean theorem, or magnitude of R is the square root of the sum of the squares. Here, the square root of 70.3 miles squared plus 14.3 miles squared, which is 72 miles, rounded to two significant figures accuracy. Step 3, find the reference angle for the resultant vector. Using the tangent of the reference angle is the magnitude of the y component over the magnitude of the x component of the resultant vector. Solving for the angle using the inverse trig function. Theta ref is angle whose tangent is magnitude arcs of y over magnitude arcs of x, or theta ref is angle whose tangent is 14.3 miles over 70.3 miles, or 11 degrees, again rounded to two significant figures. Step 4, find theta in standard position for the resultant vector r. The negative x-axis is 180 degrees, theta ref 11 degrees, resultant vector is in the third quadrant. Therefore, theta in standard position is 180 degrees plus 11 degrees, or 191 degrees, giving us a final result. Resultant vector is 72 miles at an angle of 191 degrees. Now it is your turn to work some problems.